A mass in the gravitational field has potential energy, which means it has the potential to accelerate and thereby increase its kinetic energy. This kinetic energy can be used to do work. For example, imagine you want to use a stone to pound a nail into the piece of wood, and you place the stone above the nail. When you drop the stone, gravity converts the potential energy into kinetic energy. When the stone hits the nail, it does work by pounding the nail into the wood. The gravitational potential energy is the work that a mass can potentially do by virtue of its position in a gravitational field. Potential energy is a very useful concept because it can be used with conservation of energy to calculate the motion of masses in a gravitational field. Electric potential energy works much the same way, but it is based on the electric field instead of the gravitational field. By virtue of its position in an electric field, a charge has an electric potential energy. If the charge is free to move, the force due to the electric field causes it to accelerate. So its potential energy is converted to kinetic energy, just like the mass that falls in the gravitational field. The kinetic energy can be used to do work. The electric potential energy is the work that the charge can do by virtue of its position in the electrical field. The formula for the electric potential energy is here, which is V is the electric potential, and K is the Coulomb's constant, and Q is the point of charge, and R is the distance between the charge and the point. The SI unit for electric potential energy is in volts in honor of Alessandro Volta, and 1 volt is equal to joules per coulomb. Birds don't get electrocuted on the power lines because electricity does not move through their bodies when they sit on them. When the bird sits with both its feet on the electric wire, their legs have an equal electric potential, so the electricity will not move throughout the bird's body.